Here is our video tutorial for ThinkCentral Unit 3 practice test and real test. So let's really put a lot of effort into studying and preparing for this super important exam. As always, it's most important to unpack each and every problem. So problem number 1, they're asking us to drag and drop, which we can't do on this iPad, into the correct box to show the comparisons. So looking at each problem, what they're asking here is X the answer. So is the answer in the first problem, well, in all the problems, greater, less than, or equal to the number shown? So what the strategy here is you have to look at the other factor. So if you're asking if it's greater or less than 11/4, you have to look at the other factor. In this case, it is 5/8. And you say, is 5/8 greater or less than 1 or equal to 1? And if it's less than 1, then the answer is going to be less than. If it's greater than 1, for example, in this case, you're looking at the 11/4. Is X going to be greater or less than or equal to 5/8? So you look at 11/4, you say that is greater than 1. You're multiplying 5/8 by a factor greater than 1, so the product will be greater. Same thing here. Is the answer going to be greater than 4/3? So you look at the other factor, it is 9. 9 is greater than 1, it is greater. Look at the other factor, is it going to be greater or less than 9? 4/3 is greater than 1, so it is going to be greater. 2/9 and 1/9 are both less than 1, so both of these products are going to be less than 1 because you're multiplying a part by a part, which gives you a smaller part. And in the last one, you're multiplying 5/8 by 9/9, which is equal to 1, so X is going to be equal to 5/8, but it is going to be less than 9/9 because 5/8 is less than 1. There are 2 packages of trail mix shared equally between Alicia and her 6 classmates. So important to unpack that. That means there's going to be 7 people altogether. So which model represents 2 packages of trail mix divided by 7? You can see A is not correct because there's only 5 pieces. B is 1, 2, 3, 4, 5, 6, 7. B is cut into sevenths. C. B is 1, 2, 3, 4, 5, 6, 7. So B could be correct. And D is 1, 2, 3, 4, 5, only 5 pieces. So D doesn't work and A doesn't work. So now we look at if you're going to share 2 packages of trail mix between 7 people, each person is going to get 1/7 of each bar. So this shows 1/7 of each bar, this shows 2/7 of each bar, and each person only gets 1/7. So B cannot be the correct model. So we're showing 1/7 of each bar, and then if you wanted to come up with an equation for that, you would say 2 divided by 7, or you could say 2 times 1/7. So I'm looking here, you only have 2 bars, not 7, so A doesn't work. B does work because you have 2 bars divided by 7. C is plus, so that doesn't work. And D is 2 times 7, so that doesn't work. So the correct equation would be 2 trail mix bars divided by 7, which you'd get 2 divided by 7, which is equal to 2/7. You could also do the keep change flip, 2 times 1/7, but you still end up with 2/7. Remember that a fraction is a division bar, so the simplest way to do it is 2 divided by 7 this way. So the answer here is 2/7. There's a breakfast buffet, and Mr. Walker is dividing 12 loaves of bread between 7 platters. So you've got 12 loaves of bread. I've gone ahead and drawn my 12 loaves of bread, and you're going to cut them into 7 platters. There's a couple ways you could do it. I like to use the unit fraction. I take each loaf and I cut it into 7 pieces, and each platter is going to have 1 of those pieces on it. So if you did it that way, you cut each one in. Each platter would have 1/7 on 1/7 on each platter, and there are 7 platters and 12 loaves. So each plate would get 1 of these, so you get 1/7, 1/7, 1/7, 12 times. 1/7 12 times is going to be 12 divided by 7, and you end up with 12/7 loaves on each plate, or you could simplify that to 1 and 5 sevenths. The other way you could do it is you could just take each, thing and say, well, one platter gets this, 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 and this. So that puts one whole loaf on each plate, and then you split up the 5 remainder into 7 pieces, and that would be your 5/7 there, 1/7, 2/7, 3/7, 4/7, and 5/7. Either way, you're going to end up with 1 and 5/7. And the way to do that is using the equation 12 divided by 7. All right, let's take a look at this one by unpacking it. We're going to pick a model that represents this problem. Ava here has 2 frogs, so that's Ava's 2 frogs here. This, and that's the critical part there, this, which is the 2 frogs, is 1/3 of, so this too is 1/3 of Heather's. So how much would Heather have? Well, Heather would have another third and another third. So how many frogs would Heather have if Ava had a third? Well, if Ava has 2, then Heather would have 2 and 2 and 2, or 6. So let's take that information. Let's look for a model that applies. You can see that D has 6 for Heather, 2 for Ava. So D is the correct model. Now, what equation would we use? You'd say, I like to say, well, Heather, x equals 2 times 3, or you could say Heather, if you use the keep change flip, equals 2 divided by 1/3. So that's the keep change flip. You're looking for an answer here that would give you 6. This would not give you 6. This would not give you 6. This would not give you 6. This is the only one that gives you a result of 6. So she has 6 frogs. For a snack, Miss Johnson gives her class graham crackers. She has a package of 30 graham crackers. So what I've done is I've drawn the package right there for you, and she shares it equally among 12 people. So I've divided it by 12. So you have 30 divided by 12. That's my model. Well, 30 divided by 12 is the same as 30 times 1/12. So dividing 30 graham crackers among 12 students can be found by solving. I'm not sure what they're asking us, solving the problem, and it would be 30 divided by 12, which is, you could divide it that way, 30 divided by 12. You could do the traditional way, would be 2 and 6/12, or 2 1/2, or you could do it this way, keep change flip. You could say divide that by 2 to get you 6, and that by 2 to give you 15. We actually keep dividing that by 2 to get 3, or divide that by 3 to get 2, and divide 15 by 3 to get a 5, and you end up with 5 times 1 is 5, and 1 times 1 is 2, so 5/2, or 2 1/2. So either way, we're going to end up with 2 1/2 graham crackers per student. You can check your answer by multiplying 2 1/2 times 12. You'd end up with 30 graham crackers. Question number 7 is pretty straightforward. There's just saying true or false. So we kind of go puzzled penguin on this, and you just do, numerator times numerator, denominator times denominator. So is 5 times 7 10? No, it's not 10. And 3 times 2 is not 21. So this is false. Multiplying across, 5 times 2 is 10, 3 times 9 is 27, so that is true. 5 times 7 is 35, and 5 times 8 is 72. So that's also true. 1 times 3 is not 4, and 5 times 2 is 10, but since that's not true, that answer is not correct. So only for questions 2 and 3 are true. The first and fourth are false. Choose yes or no for each equation and tell whether the equation can be used to solve this problem. One needs to measure 6 cups of flour for a recipe. So I've drawn a picture here showing 6 cups. There's my 6 cups. He only has a 1/4 cup measuring cup. So that means out of this cup he would have to take away 1/4, another quarter, another quarter, another quarter, or 4 times he would have to take away 4 times, handwriting, 4 times from each total cup for each one he needed. How many times must he fill the cup to get 6 cups? Well, The way I solve it is I just draw my picture. So he has to fill up his cup 4 times from each whole cup. So 4, 4, 4, 4, 4, 4, or 6 divided by 1/4 is the same as 6 times 4, which is 24 times. So the answer is 24 times. We now have to look at which one of these makes sense to help us solve the problem. Well, it's not 6 times 1/4, it's 6 divided by 1/4, so no on this one. 6 times 4 is going to give us the correct answer because we did that right there. 1 times 4 6, no, that's only give us 4 6, so no. 6 divided by 1/4, yes, I did that right there, so that is true. And 6 divided by 4, you're not dividing 6 by 4, you're dividing 6 by 1/4, so no. So the only ones that give us the correct answers are 6 times 4 or 6 divided by 1/4, and those are the keep, change, flip strategies. So which diagram represents this division problem? Ben has a piece of cord that's 60 feet long, so I've drawn the cord right here, and he wants to cut the cord into pieces to tie up a tomato plant. How many pieces can he cut if each piece is a 1/4 foot? So what I've done is I've taken 60 and I've just kind of drawn a quick model here. Each line represents a 1/4 foot, so there's a lot. And the way I look at it is, well, I don't want to do 60, so what I'll do is I'll say, I'll just draw 1 foot here. And how many pieces of cord would you get if you cut 1/4 pieces off each foot? And you'd end up with here 4 pieces. So 1 divided by 4, 1 divided by 1/4 is going to be 4 pieces. So it's 4 pieces in 1 foot, and you have 60 feet. How many 1/4 foot long pieces are there in 60? Well, it's 60 times 4, which would be 240. So I think the diagram that C can't be right because there's only 3 pieces here. He needs a 1/4, and that's 2 pieces. That is 5 pieces. The only diagram that works here is A. 1 foot cut into 4ths would be the correct diagram. So if you had the dividend, remember, is 60 feet long, so that doesn't change. So it's not 1/4 divided by 60. It's not 4 divided by 60. It is 60 divided by 1/4. How many fourths are there in 60? So the correct answer is 60 times 4, which is 240 pieces. Of the 5th grade students, 16/20ths went to the book fair. Of those students, 20/25ths bought at least 1 book. So they're asking what fraction of the 5th graders bought at least 1 book. So of, we know, means times. So we're going to take the original number, which is 16/20ths, and we're going to multiply it by 20/25ths. Of means times. So B is the correct equation to use for this. Now we just solve it. Well, what I like about this a lot is I see on the diagonal here 20/20ths, so I can just simplify that by dividing 20 and 20 by 20, giving me 1 and 1. So this problem turns out to be fairly simple. It is 16 over 25. So 16/25ths of the students bought a book at the book fair. Always look for the slash dash or simplification before you multiply. Marie plants flowers in a flower bed. I've gone ahead and drawn the picture of the flower planter. It's 2.5 feet long by 1 1/3 feet wide. She plans to cover the entire thing with fertilizer, and that means area. So area is the amount inside. We have to remember that to determine area, you multiply the length, which is 2.5, times the width, which is 1 3/4. So to solve this problem, we're going to have to multiply length times width, which will be 2.5 times 1 1/3. We have a couple ways to solve this. We can use the improper fraction method, parts times wholes plus parts, 2 times 2 plus 1. 2.5 is the same as 5 halves, and 1 1/3 is the same as 4 thirds. So this is probably the easiest way to do it. I can't simplify here. 4 and 2 both have a common factor of 2, so 2 goes into 2 once and 2 goes into 4 twice. So you end up with 5 times 2 as your numerator, which is equal to 10, and you have 1 times 3 as your denominator, which is equal to 3, and you can simplify that into 3 and 1/3 square feet. So that's one way to do it, and the other way to do it would be to use a partial products method, which is more difficult, but I mean it's just more complicated, but it's also fairly easy. go 2 1/2 this way by 1 1/3 that way, and then multiply each partial product, add them up. So that's 2, that's a half, that's 2/3, and that is 1/6. So if we add all these up, we're going to get, I'm going to add all these up. I'm going to say they're unlike fractions. I'm going to get a common denominator of 6, so it's 3/6 plus 4/6 plus 1/6, which would be a total of 8/6. And so it would be 2 and 8/6, which is the same as 3 and 2/6, which is the same as 3 1/3. So either way we get the right answer. I prefer the improper fraction method, but you can solve it either way. Very similar problem to the one we had before. Of Simon's collection, 19 25ths are quarters. Of those, 2/7 are state quarters. What fraction of Simon's coins are state quarters? So you start off with your original amount, 19 25ths, and you multiply that by 2/7 because it's of. In this case, you cannot simplify. I don't see any common factors, so we multiply straight across, and you get 38 over 175, I believe, and so 38 over 175 coins are state quarters. This is a very odd number, but I believe that is correct. A square, do not enter sign, has a height and width of 3 1/4. This is key right here, a square. A square is the same on both, all four sides are the same. So it's a 3 1/2 by 3 1/3 by 3 1/3. So will the area of the sign be greater or less than 3 1/3? Well, you're going to multiply 3 1/3 times 3 1/3, and that would mean you're multiplying by numbers that are greater than 1, so it will be greater than. Multiplying a factor by a number greater than 1 results in a product greater than the factor. To find the factor, multiply 3 1/3 times 3 1/3. Since 3 1/3 is greater than 1, the product must be greater than 3 1/3. So what are we going to do to solve this? We're going to multiply 3 1/3 times 3 1/3. And to me, this is fine here, but then you see the addition here, so that doesn't work. It's 3 1/3 times 3 1/3. This is the improper fraction method. 10/3 times 10/3, and that would give you a total of 100/9. And we could simplify that down to 11 1/9. So I think that D is the correct answer, and it should be 11 1/9 square feet. Patel drew an area model to help him solve this multiplication problem. Let's use these numbers here to plug in. So what do you see here? Well, you have to see that this dark line here, that's a hole, and that is another hole. So you have two numbers greater than a hole. Well, this whole thing is covered in, so that's one hole there, and that is the same as 3/3. And this here is 2/3. So this number represented down this way is going to be 5/3. So 5/3 is the measurement going down this way. Now going across, you have red, you have 1, 2, and 3. So you have 3 parts out of 4 going that way. So it would be 3/4 that way. Now to solve it, you just multiply 5/3 times 3/4. And this is not correct. This is also not correct. This is correct. 5/3 times 3/4 is equal to 5 times 3 over 3 times 4, and they've cross-canceled or simplified that way. So that will help you. That's going to be 1 and 1. 5 times 1 is 5, and 1 times 4 is 4. So the answer is going to be 1 1/4 square units. So these should be fairly simple. We've done a lot of these in class. Is the answer going to be greater or less than 2/4? Well, what are you multiplying by? You're multiplying by 8/5. 8/5 is greater than 1. Therefore, the answer will be greater than 2/4. When you multiply a number greater than 1, you get a product greater than the factor. Same problem, multiplying 7/7. So 7/7 is going to be equal to 1, and we know that multiplying any number by 1 gives you the same number, so your product is going to be equal to 3/9. Asking us to drag and drop, comparing products. So Is the answer going to be greater, less than, or equal to 2/3? Well, this one's going to be equal to 2/3 because you're multiplying by 7/7, so that one goes there. This one's going to be greater than 2/3 because you're multiplying by 6/5, which is greater than 1. That's going to go there. This one's going to be less than 2/3 because you're multiplying by 1/5. It goes there. This one's going to be greater than 2/3 because you're multiplying by 4 wholes, which is greater than 1. So that's going to go there. Multiplying by 6/7 is less than 1, so the product's going to be less than 1. And multiplying by 2 wholes, which is greater than 1, the product's going to go there. It's going to be greater than 2/3. Hannah wants to divide 7 oranges equally amongst 4 children. So we're going to be cutting each orange into 4 pieces. So you have 1, 2, 3, 4, 5, 6, 7. And she did cut them each into 4 pieces. Each kid is going to get 1 piece of each orange, like that. So yes, this model is correct because you have 1, 2, 3, 4, 5, 6, 7, and 1, 2, 3, 4, 5, 6, 7. Each kid gets 7/4 of each of the oranges altogether. Is it correct? Yes. Each child would get 7/4 oranges or 1 3/4 oranges, and the model does show that 1 3/4. Axel's going to paint his doghouse using leftover paint. He has 2 identical walls, so I'm going to definitely draw pictures here to represent the 2 walls and 2 identical roof sections. So let me draw 2 roof sections. The dimensions of the walls and roof are listed below. So the wall is going to be 1 1/3. Each wall is 1 1/3 by 2 1/8. So 1 1/3, 1 1/3, 2 1/8 each wall. And the roof is going to be 1 1/2 by 2 1/12. So you have to draw each thing to make sure we have everything covered. Does he have enough? He has enough paint to cover 6 square feet. For which part of the doghouse will Axel have enough blue paint? 2 walls or 2 roofs? So we're going to pick. We're either going to find out 2 walls or 2 roofs. He can't do both. So we'll find out the area for the walls and the area for the roofs, and then that will tell if they're greater than 6, we won't have enough paint. If they're less than 6, we can paint those parts. So let's start off with a wall. It's 2 1/8 by 1 1/3. So let's use the improper fraction method. That's going to be 4/3. 1 1/3 is 4/3, and then 2 1/8 will be 17/8. So let's find out the area for this wall. I can simplify it this way. Divide by 4 and divide by 4. So I end up with 17/6, which is going to simplify to 2 5/6. So I have 2 5/6 for this wall and 2 5/6 for the other wall, giving me a total of, let's see, what's 2 5/6 times 2? So 17/6 times 2, I'm going to simplify this, ends up with 17/3, which is 5 2/3 square feet. So the area of both walls is 5 2/3 square feet, and that is less than the 6 feet that I have. So yes, I think I can paint the 2 walls. But now let me take a look at the roofs. So 1 1/2 is 3 halves. 2 1/12 is 25/12. I can simplify this diagonal here, dividing both by a common factor of 3, 1 and 4, so I end up with 25/8, and 25/8 will simplify into 3 1/8, and I know if I double that, I'm going to end up with 6 2/8, and that's bigger than, that's square foot, and that's bigger than the amount of, I only have 6 square feet of paint, so I will not be able to paint the roofs. I'm going to have to paint the walls with my 6 square feet of paint. Some of these problems are pretty tricky, so make sure you're studying this, you're completing the Nearpod practice test, you're completing the practice test in the book, and you're completing the practice test on ThinkCentral. If you do all those and you ask a lot of questions, it should be a fairly easy test for you, and you should do very well. All right, so work hard and ask for a lot of help if needed.